In this section, we are going to look at a new type of function that is called a logarithm. We've been studying exponential functions, and so we know that when 2 to the second power equals 4, we know that 2 was the exponent that made it equal to 4. If 2 to the third is equal to 8, then 3 is the exponent that makes it equal to 8. But for what value of x does 2 to the x equal 6? Well, 2 to the second is 4, 2 to the third is 8, one's too low, one's too high. It's got to be something in between, but how do we figure out what that something is? That is where the logarithm comes into play. The logarithm is the inverse function of the exponential function. And here's the way the two are related. When we look at, let me get my highlighter here. When we look at this, okay, it has base b. We're always looking for what the base is, okay? And so the base of an exponential is the same as the base of a logarithm, and we refer to them the same. We call them the base in both instances. Here, b to the x, b is the base, and when we read this expression, we read this as the log base b of y equals x. Okay, we wouldn't say log b of y, you would say log base b. So make sure you know that that's how we read this. Okay, so notice what happens here. Here's what I want you to remember that I find very helpful to help you remember how to switch things around. Logs equal exponents. That's always how they're going to be set up. And that's a really important thing to remember because it helps you decide where things are supposed to go. So notice that it's b to the x power equals y. Now when we do the logarithm, the log base b is equal to x, so we're taking the log base b of y. That's how we figure out what this is. So let's look at a couple of examples down here and see if we can't figure out how to write this down. So we want to take these log equations and rewrite them in exponential form. So A says the log base 2 of 32 is equal to 5. Now here's the deal. Logs always equal exponents. And the base of the log is the base of the exponential. So if we write this in exponential form, 2 is going to be the base, 5 is going to be the exponent, and that means the only thing I have left is 32. So you can check, does 2 to the 5th power equal 32? 2 times 2 times 2 times 2 times 2, it does. We get 32. Okay? Example B. The base of this log is 7. The log is equal to 0, so 0 is the exponent. And the only thing that we had left was the 1. Does 7 to the 0 power equal 1? Yes, it does. So at this moment, I would direct you to pause the video, try C and D so you can see if you understand this before we move on to the next thing. Once you've done C and D, come on back and you can check your answers to see if you're on the right track. So for example C, the base is 6. It's equal to 1, and that is equal to 6. 6 to the first power does equal 6, so we're probably correct. On example D, the base is 1/4. The exponent is what it's equal to, so that's -1. Now here's what's really important. If you're going to do a fraction to an exponent, you must have parentheses. It's not optional. So, does 1/4 to the -1 power equal 4? It does, because if you remember, negative exponents make it the reciprocal. 1/4 would change to 4/1, which is just 4. Okay? Now, we use this idea to evaluate logarithms to figure out what they're equal to when they work out nicely. Okay? So, for example, in part A, the log base 4 of... Now, that question is saying 4 to the what power equals 64? Okay? Think about it this way. This is going to be equal to something. And if we rewrite it in exponential form, that's the question it's asking. 4 would be the base. The exponent is unknown, but we want it to equal 64. So you just kind of guess around in your calculator. 4 to the first is 4. 4 squared is 16. That's not big enough. 4 to the third power just happens to be 64. So the answer is 3. And it's 3 again because 4 to the third power is 64. Now, when you see decimals like this, I find it much easier to convert it to a fraction. So 0.2 is 2/10, which reduces to 1/5. So maybe let's think about it that way, the log base 5 of 1/5. Because here's what that's saying. 5 to some power is equal to 1 over 5. What kind of an exponent would cause the 5 to turn into 1 over 5? Well, it would have to be a negative, and since the 5 didn't change, it would be -1. Okay. Again, I would encourage you real quick to put the video on pause so that you can try C and D on your own before you come back and check your answers. So for C, we know that the base has to be 1/3. 1/3 to some power has to equal 81. And here's the deal. For it to change from a fraction to a whole number, it's got to be a negative exponent. So I know that my exponent has to be negative. If it was -1, that would turn it into 3, but that's not going to be enough, so I have to guess around until I find 3 to the what power is 81. 3 squared is 9. 3 to the 7th is 27. 3 to the 3rd is 27. And then 3 to the 4th is 81. So the answer here is -4. On the last one, the answer you should have gotten is 7. Because 2 to some power is equal to 128. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th power, that's my dog shaking. 2 to the 7th power is equal to 128. So the log base 2 of 128 is equal to 7. Now, your calculator doesn't do all logarithms. There's infinitely many, so we would have to have some way to do that. What we need to know is the common log versus the natural log. These are the two that most calculators will do. Some of you have fancier ones that'll do it. That doesn't mean you don't need to know this because it's going to matter when we're solving equations, okay? So the first one is the common log. And we use the common log when that's a log. It's a log base 10. So this is what you see in your calculator, the log of x. That only will evaluate a log base 10. So 10 to the something power equals whatever you're trying to do. Okay, that one it will do base 10. We never ever write it this way. We only ever write log of x, and that stands for the common logarithm base 10. Now that number e that we talked about yesterday, if we do the log base e, same thing, we wouldn't write it this way. That's what the natural log of x is, that ln button, which was where we found the e to the x button. That is a log base e. So we have common logs and natural logs. Those are the two that all calculators, scientific or higher, will do. So take just a second on your own, put the video on pause, and do A, B, C, and D on your own. Put those numbers in the calculator, and then unpause it and check if you got the same thing as me so you can be sure you're using your calculator correctly. Through the magic of video and the iPad, here are the answers to all four. And so just take a second to check and see if those are correct. If those are what you got, then you understand how to use the calculator and you're ready to move on. So, the last thing, what is this doing? Okay, is some of the applications for logarithms. So here's an example of a problem where we have to solve evaluate an expression that has a logarithm. So the wind speed in miles per hour near the center of a tornado can be modeled by this equation, S equals 93 log D plus 65. Now, that 93 works like a coefficient, just like if I said 93x, that means 93 times x. So 93 log D means 93 times the log of D. Where D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado center. So we know the distance, that's D. So we're going to go ahead and plug that into our equation. So we are going to have that S is equal to 93 times the log of 220 plus 65. Now, what base log is that? Since it doesn't say, it's a log base 10. So grab your calculators, and we're going to say 93 times the log of 220, enter, plus 65, enter, and we get 282.8, and what is this in? Miles per hour. That's how fast the tornado was going based on its distance. So it's one application there. All right. That is where we are going to stop for today. You need to really, really practice rewriting and understanding this because it's going to make a world of difference as we continue on through the rest of the time. Okay? I will see you guys later.